Welcome to AutoSens, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information for the purpose of connecting the global community of engineers, scientists, and other automotive industry experts. One such expert joining us today is Gil Golov, Technical Director at Socionext. And Gil, good to see you, friend. Welcome to AutoSens.
Thank you very much. Pleasure to be here.
Gil, to begin, what are the reasons that OEMs and Tier 1s, why do they consider designing their own SoCs for autonomous driving based on chiplets or even monolithic die instead of relying on maybe more standard components that are available today?
Right. So today, most of the systems are level 2 autonomous driving. We are talking about lane assistance, etc. There are sometimes good reasons why automotive would like to design their own SoC for level 2. But the real challenge comes when we are talking about level 3 plus, level 4, and level 5, where there is an exponential increase of compute performance and AI. Building a system based on the standard GPUs or general purpose NPU ends up with not so great energy efficiency because they are general purpose solutions. We are talking about hundreds or even thousands of watts. The solution for that is to design a dedicated NPU which is optimized to a certain set of algorithms the automotive OEM would like to have. This helps a lot in cost, system complexity, and power. This is the first reason. The second reason, there is a movement now in car architecture towards software-defined vehicle and high-performance compute, right? So building a high-performance compute, what we are doing, we consolidate multiple ECU functionality into one central place, and the complexity comes to one place. Now, car OEM would like to optimize it as much as it could be to have an edge, and it's easy to optimize one place and multiple ECUs. They would like to have full control of the architecture on the interfaces or the ingredients of the high-performance compute. And therefore, that's a tendency, and I can tell you, Carl, that the fast-moving, actually, car OEM in the world is already designing such solution for those reasons.
Let's take that and then look at the bigger picture. So what makes chiplet-based architectures then so compelling for the future of autonomous driving and high-performance compute?
So chiplets are actually systems that consist of multiple silicon dies placed very close to each other, attached on a silicon interposer. So the advantage that this structure actually brings is, first of all, super high connectivity at low power between the silicon die because of the silicon interposer UCIe die-to-die interface as a fine pitch. It also, this structure enabled to use high bandwidth memory that supports bandwidth of terabyte per second, which it actually requires for level 5 and so on interface. It's funny, but the data center world that already building high performance compute do use chiplets today. Automotive now starting to use high performance compute with this similar performance require, looking seriously about it. Another advantage of chiplet is the scalability and modularity. You can, build a system, think about automotive AI, level 3, level 4, level 5, without changing one chiplet as a neural processor and keeps the rest the same. Fast time to market and scalability. That's a motivation.
Socionext has a strong track record in custom SoC development. So how does that experience then give you an edge when you're creating these tailored chiplet-based solutions for OEMs and Tier 1s?
Right. So Socionext is a merger of Fujitsu and Panasonic Semiconductor. We have 40 years experience in SoC design. So Socionext itself the structure to design and manufacture custom SoC. We have completed hundreds of SoC in the past years in all in volume productions. And of course, it's very complex. Dozens of engineering steps are involved. We have all the teams in place and the experience, but more than that, we have a unique business model. We call it Solution SoC, where we engage with customer at a very early stage before the customer even, just when they start to think about chips, so maybe it's a good idea to design an SoC. We're going with the customer through the trade-off, what makes sense, even the basic question like which technology to use, which interfaces to use, what are the ingredients. This is highly appreciated by our customers.
We're speaking with Gil Golov, Technical Director at Socionext. And Gil, what are then some of the key technical challenges that chiplet-based designs help solve when compared to traditional SoCs, especially then in the context of ADAS and Level 4, Level 5 autonomy?
Right. So we are talking about high data speed bandwidth between the chiplets. If we compare it to just the old technology, which we have a PCB board with multiple SoCs and GPU, delivering the data consumes substantial amount of energy. Using UCIe technology and a chiplet base reduces significantly the amount of energy spent on the system level. We enable using high bandwidth memory in range of terabyte per second, and this can be served as a multi-purpose and central, actually, DRAM to serve all chiplets there. We are talking about the flexibility, so automotive would like to have, and scalability and fast time to market.
You also have highlighted the importance of collaborations. So, what role then do ecosystem partnerships and open standards like UCIe, what role do those play in making chiplet-based strategies viable at scale?
Yeah, so actually what the industry would like to have, we are not there, by the way, today. We'd like to have the possibility that the SoC integrator will pick up chiplets that are just freely available on the market. But it's just impossible to do it today because there is no lack of standardization, how to interface on the interface level, on the protocol level, and above all, how to test it. As the system integrator now is responsible to deliver a chiplet, which is a tested solution. And today, the way to solve the problem either there is one system designer, house designer designs the chiplets and integrates them, or collaborates very closely with another chiplet supplier. But we are not in a place where today in the industry when you just can pick up a chiplet and connect it to the system. We want to be there. UCIe is one of the activity talking about die-to-die interface, but there are other activity, ASRA in Japan, talking about semiconductor for automotive and reliability, where Socionext is very active. In Europe, there is a IMEC organization looking also about chiplet. We are also active. So it's very welcome and needed in the industry to have standardization and tight collaboration.
We've been speaking with Gil Golov, Technical Director at Socionext. A pleasure to have you with us, Gil, and looking forward to seeing you in person in Barcelona for AutoSens Europe 2025, October 7th through the 9th. Until then, though, friend, thank you for being with us virtually.
Thank you very much, Carl. It was a pleasure to be with you. By the way, I will be giving a presentation in Barcelona about chiplets in automotive, and everyone is welcome to join. Thank you very much.
Indeed, we'll look forward to that, Gil. For more information about Socionext and to find out more about our upcoming events, see the links in the description or visit auto-sense.com. That's auto-sense.com. For more in-depth interviews like this, subscribe to the AutoSens YouTube channel and follow AutoSens on LinkedIn. In Detroit, on behalf of AutoSens, I'm Carl Anthony.